This week we've got the Large Hadron Collider, Directed Energy Deposition robots, ankle repair, automotive production lines, and more right here on Vision Miner 3D Printing News, so let's get into it! Starting off today, we've got CERN and 3D Systems 3D printing parts for the Large Hadron Collider. Engineers over there have sought to develop a series of cool bars for reducing the temperature of the system used for the LHC Beauty, or the LHCb, specifically for scintillating fibers. As the name suggests, these are optical fibers that emit tens of photons when a particle interacts with them. Each scintillating fiber making up the subdetector is 0.25 millimeters in diameter and nearly 2.5 meters in length. And there are more than 10,000 kilometers of scintillating fibers that will be integrated into the LHCb, which will be hit with neutrons constantly. Radiation damage caused by this process will in turn create dark noise in the readouts. To keep the SIPMs cool, shielding for the scintillating fibers is necessary. The parts they designed had a design that was so beautiful but not producible in the usual ways, so they turned to 3D printing. The resulting parts are topology optimized and 3D printed. 3D Systems actually designed and produced 300 cool bars for CERN, capable of cooling the system to 40 Celsius, negative 40 Celsius that is. The team had to adjust some parameters to achieve the required wall thickness of 0.25 millimeters, and the 263 millimeter long parts needed a flatness with precision of 50 microns over their entire length, or just over 1/1000th of an inch. The cool bars themselves are welded together out of two mirrored 3D printed parts made in a titanium alloy. Each cool bar has parallel cooling channels and is rated to last an entire decade. Moving right along, we've got ESPRIT and Alma partnering for an end-to-end programming for robot additive DED. So, DP Technologies entered into a partnership with Almacam, a developer of CAD/CAM software specifically for sheet metalworking, cutting, and robotics, to create a complete programming offering for robot additive Direct Energy Deposition, or DED. The firms will combine their areas of expertise within advanced toolpath planning in both subtractive and additive areas, and in robotics trajectory computation, to provide customers with an end-to-end program for robot additive DED. So, additive DED involves the creation of parts by melting and fusing materials as it's deposited, using multiple 3D printing technologies such as wire arc additive manufacturing, or WAM, which are generally faster than, say, powder bed fusion style printing. Robotic DED machines also cost significantly less than machine tool-based DED machines, which can cost up to millions of dollars. The technology partnership between ESPRIT and Alma will produce a complete workflow software, equipping users with dedicated additive toolpath planning and programming. The software will also provide robot programming, simulation, verification, alongside collision detection and code generation. I love it when we can do things faster for less money. And if you're liking this video, let us know by hitting the like button. It helps us get this out to more people by poking that YouTube algorithm, you know, the robot masters that are controlling the internet, and we really appreciate that like button. And while you're at it, you might as well subscribe, because we've got some football news coming right up. European football, that is. FC Barcelona has joined the Triankle project to trial regenerative 3D bioprinted ankle implants. Spanish football club FC Barcelona's R&D lab, Barca Innovation Hub, has joined the EU-backed Triankle project to help test its upcoming 3D bioprinted ankle implants. With 12 companies in the group, including bioprinting firm Cell Inc., they are developing collagen-based cell grafts to reduce recovery times by up to 50%. In joining the program, Barcelona has now agreed to test the transplants on its amateur squad, the guinea pigs, with the goal of optimizing performance and preparing them for a future commercial release. I think my jiu-jitsu guys may be interested in this technology. So they say launching this technological platform will enable development of future regenerative therapies for joint tissues in weight-bearing joints. The Triankle project is part of the wider European Horizon 2020 program, an €80 billion plan that gives additional funding to certain areas of research. Horizon's €5.9 million Triankle program, due to start next year, will see its members develop therapies to accelerate the recovery of ankle joint tissues. Barcelona's role in the project is to perform preclinical assessments of the implants by testing them on its amateur athletes and retired former players. As a result, Barcelona may be testing the new hydrogel on its squad, but don't expect the superstars to be receiving additive treatments just yet. However, the project's goal isn't just to reduce the club's injury list, but more so to unlock 3D bioprinting's potential and drive applications in the medical industry. Check out more from the link in the description. Next, we've got Renault to transform its Flins site into a refactory circular automotive production line. That's right, the multinational car manufacturer has announced that it's creating a refactory that's dedicated entirely to sustainable automotive production. The facility, which is currently being built near Paris in the French town of Flins, will focus on reducing waste and retrofitting vehicles, as well as offering a 3D printed spare parts service. As part of its broader transformation strategy, Renault designed it to reduce their industrial footprint and to take advantage of sustainable opportunities. They aim to minimize downtime and recondition the cars in an average of just 6 days, enabling them to restore over 45,000 vehicles. The complex is also set to house an additive manufacturing center of excellence, which will prototype 3D printed spare parts and identify potential opportunities to deploy the technology in predictive maintenance applications. 3D printing is already being utilized in various ways by the automotive industry. BMW, for example, recently opened a dedicated innovation campus, working to optimize additive technologies for the comprehensive use across its entire business. The company is also collaborating with 11 industry partners as part of its IDAM project, which aims to 3D print over 10,000 spare parts. This trend of replacing legacy components with additive substitutes can be seen all throughout the industry, and Volkswagen has been fabricating parts for its Golf GTI since 2017. We've actually got an entire video coming soon on additive in motorsports. It's going to be a really cool one, so make sure to hit the subscribe button so that you see when it comes out. Similarly, Delmir has introduced digital warehousing within its heavy-duty vehicles, using it to fabricate several spare parts on demand. Although these initiatives are designed to lower manufacturing costs and lead times, they also reduce material waste by ensuring that they only produce what's needed. Moving right along, we've got the Lawrence Livermore National Laboratory 3D printing custom glass lenses via direct ink writing technology. A team of research over at LLNL have used multi-material 3D printing, namely direct ink writing or DIW, to fabricate customized gradient refractive index glass optics. The approach allows for a number of optical functions to be programmed directly into flat glass components, functions that would otherwise require curved lenses. The scientists over there believe that their approach can offer unseen design flexibility for glass-based parts, and they see potential applications in military optics as well as virtual reality eyewear. So the most basic example of a GRIN optic is the human eye, which changes its refractive index based on the ambient light levels and the distance of an object being viewed. Well, there are mechanical variations at work in that many species eye lenses change via the concentrations of structural proteins, which can form gradients for different focal points. At its core, the experiment involved actively controlling the ratio of two glass-forming inks in a paste-like blend. The various blends were then developed as raw 3D printing materials and then densified to turn them into glass. As a final step, the team also finished the prints with conventional optical polishing to produce usable lenses. Dyla Spears concluded that this is the first time we have combined two different glass materials by 3D printing and demonstrated their function as an optic. Although demonstrated for GRIN, the approach could be used to tailor other material or optical properties as well. Further details on the study can be found on a paper titled 3D Printed Gradient Index Glass Optics. In a similar study earlier this year, researchers from the ICMCB CNRS laboratory and the University of Bordeaux developed a method of 3D printing phosphate glass via FDM technology. By the way, we love your comments, so let us know what you think so far, especially those of you who are sharing these videos on forums and around the internet on Facebook, and hit that subscribe button if you haven't already. Moving right along into the news blitz. First, we've got Volkswagen enhances automotive design with 3D printing. Next, in the food industry, we've got Savor Eat and Meat Tech 3D advancing the Israeli 3D printed food sector. We've got Zurich scientists develop a 3D printed microbot for drug delivery inside the human body. Getting a little crazy there. Mitsubishi also concluded a metal powder licensing agreement in the lead up to a full-scale additive manufacturing business rollout. Syntrit has launched a new PA11 or Nylon 11 ESD safe 3D printing material. 3D PBM's new December report on trends for the 2021 additive industry. We've got UpNano developing a high-resolution desktop 3D printer for micro parts. Meltio also launched their 3D printing toolhead to enable hybrid manufacturing with both subtractive and additive components. And Siemens has used additive manufacturing to create turbine blades with internal cooling channels and improved efficiency. I think we're going to do another video on that one, so stay tuned. By the way, if you guys are using 3D printing in your business or your channel or whatever, shoot us an email with some pictures or videos and we'll feature you in an upcoming episode. Literally, don't miss out on this awesome opportunity for some free advertising. Just make sure YouTube Spotlight is in the subject line or your email to contact@visionminer.com and we'll get you in there. Anyway, go ahead and leave a comment. Let us know what you thought of this video, news stories that maybe we missed and you thought were cool, or of course critique on how we can do better. At Vision Miner, we specialize in functional 3D printing, specifically high-performance plastics like PEEK, Ultem, PPSU, and more. If you're interested in those or use those in your business currently and want to save some money using 3D printing, definitely feel free to reach out or check out our website, and we'll help you make the right choice for your application. Give us a call or shoot us an email. We're always here to help. Anyway, have a positive rest of your day, and I'll see you on the next video.